Right, today we'll do another math problem, and today we'll continue on a little bit of trigonometry. Um, just some basic trigonometry. We will review something that is called before we go forward with trigonometry. We will review something that's called Pythagorean Theorem. Um, it's called it's called Pythagorean Pythagorean Theorem. Right? So based on this, actually this look like supposed to be an N. It is an N. I just wrote it like an M, but right. So basically, what we'll be doing is that we will do a triangle. Let's say that we have a triangle like this. If I can do it more straighter would be better. so let's say that you do a triangle like that, right? And then all right, so all right, so let's say that we have a triangle like this, right? And this triangle is a right angle, right? So this is only geometry, right? So basically, it's the Pythagorean theorem, right? And what the Pythagorean theorem says is that the sum, so it will say that the sum of, so basically is a squared plus b squared equal to c squared. So that is the Pythagorean theorem, right? So a squared plus b squared is equal to c squared. Well, we know that this is a c, right? So now, but the bottom line here, well, what Pythagoras does is says that this c right here, which we will see is called the hypotenuse on trigonometry, this side right here is supposed to be larger than the sum of this for this to make sense, right? So basically c squared, which is the side opposite of the right angle, right, is c, right? In other words, this is c. You can say that is b. You can say that is a, right? So you can say that this is, oops, why did I put a square? I don't have to put a square in there. So that basically is the right triangle in basic geometry, which is basically Pythagorean theorem, right? Oh, we just so now let's say, for example, like we have something like we have that A equal 1 second, let me just erase that. So let's say that A here is equal to 4 and B is equal to 3, right? And we need to find C, right? So here what we'll do is we come here and we said, okay, so 4, so A is 4, so we do 4 squared and B is 3, and then we say 3 squared is equal to C squared, right? Now, so now we said that 4 squared is 16, right? 4 squared is 16 and 3 squared is 9, so therefore is equal to C on this side, but I'm not done yet, right? I need to add those two, which is 25 is equal to C, right? And then we take the square root of that and we say that C is equal to 5. And we only dealing with the pure side of, when you take the square root of something, to be technically a plus or minus, but in this case, we're only dealing with the positive sign, right? So that's why, the hypotenuse has to be a positive number all the time, right? So, okay, so based on that, right? Let's say, for example, so you don't have an A and B, but you have a C, and you want to find A, for example, right? Or B, okay? Okay, so let's say that, let's just test this out. You can find any side of this triangle, right? So we have A squared plus B squared equal to C squared. And then let's say that we have A equal 4 and Z is equal 5, right? Okay. So let's do the math and see, right? So what we do, we substitute those numbers in the formula, right? And we do, okay, we said, okay, so we have an A, right? So now we do so now what we do is we do 4 squared plus B. We try to solve for B, right? Try to solve for B. Try to solve for B. And that is equal to 5, right? We have 5. So we square the 5, right? So now, here in this case, we have 16 plus B squared is equal to 25, right? So we take 16. We take 16 on both sides, right? And those just simply go away. And then we get what? We get, in the other side, we say 25 minus 16 is 9, correct? So So we say that b squared is equal to b squared is equal to 9, right? And we take the square root on both sides of that. So we said that b is equal to 3. And we got the same answer, right? Okay. Okay, so we got that, right? Now let's so in this case, for example, in this case, if somebody give you the answer, they said, okay, I give you the numbers. What is the hypotenuse, right? So somebody says, what is the hypotenuse? So you do this and you find the C, right? So you can say that, whatever, A is 4, B is 3, and C equal to question mark, right? And you do that and you find the values of whatever sides are missing, right? Now let's take this example and let's do a little bit of the same thing in trigonometry. So I don't know if I can actually copy this. No, I can't. I cannot do it. I cannot do this now. Okay, I had to redraw another triangle. But that's okay though. Okay, so let's say, for example, that we do another triangle. And okay, so actually this is not doing so good. Okay, so so we have this angle right here. Like say, for example, that you have this angle theta, right? And here you got the little thing for the we got the little thing here for the right triangle, right? And here we have theta. Alright, so we have data. And then remember when we did this, we found out, we did the introduction and we wrote something that's called SOHCAHTOA, right? I think you should remember from the last video that we had the SOHCAHTOA. But let me just write this side first. So let's say, for example, you want to do B here, you want to do A, and you want to do C. All right. But instead, just put numbers on it, right? Let's put numbers on it. Let's put values in here. Let's put 3, let's put 3, let's put 4, and let's put 5. Okay, so we call this the hypotenuse. This side right here is called the hypotenuse, right? So it's called that hypotenuse. Hypotenuse, right? So hypotenuse is what we're looking for, right? Actually, now looking for, we will use the hypotenuse. Sorry, let me just clarify myself on that. So we will use the hypotenuse and all these numbers to find the ratio of each function. For example, right? For example, in last video we said that sine of theta equal to opposite, right, over hypotenuse, right? Right? So, and we say that cosine of theta equal to adjacent over the hypotenuse, right? And then we say that tangent of theta equal to sine of theta over cosine of theta. Okay, so basically also you can say that the tangent of theta is equal to just the opposite over the adjacent, and that also I think is a good valid argument. So we have the functions, right? We have the functions, and then we need to actually just see if we can actually do some problem. Okay, so let's say, for example, let us do it this right now here, and say that if we can actually say that, you know, tangent is the same thing as saying tangent of theta equal to opposite over adjacent. Okay, all right, so let's keep going, and based on that triangle, let's say that we want to find sine, cosine, right, and tangent, right? So okay, so let's do it. Let's do it, right? And let's say that we need to find sine of data equal to what? Isn't that equal to, if you look here, if you go back, it says sine is opposite over the hypotenuse. So this is the opposite of angle theta. If I come straight here, change the color. If I come straight from this angle all the way down here, that is the opposite side, right? So I am pretty sure you agree with me on that. So if that is the opposite side, then what we can do, we can actually find the angle, right? Okay, so we can actually say, okay, or the value, not the angle yet, but the value, right? So this is what happened here, right? So let's say, for example, that we know already, A and B, right? What is adjacent and what is the opposite side. So in this case, the opposite side is 4. And the hypotenuse, because it's sine, we use 5, right? And when you plot that in the calculator, is equal to it's kind of small, so it's 0.13. Let me see what mode I am at. I am in degrees, so I need to change that to radians and see. Okay, so if I do 5 over 4 sine of 5, 4 over 5 is equal to 0.71, right? So this right here, the value of this at this point is equal to 0.717. See that? Okay, so basically that is it, right? Now let's do the cosine real quick. And we can say that the cosine, the exact same. So cosine of theta equal to what? Is equal to 3. So it's equal to 3 over 5, right? Because that is the adjacent side of the triangle. So here, let me just put an arrow right there. So this is the hypotenuse, right? So this is the adjacent. Okay, so the adjacent of the angle is 3. So basically, we say that the cosine of that is nothing but the ratio of 3 over 5, which is 5 in the hypotenuse, right? And usually that gives you a number. So 3 over 5, 0.82. So the value for this will be 0.82. All right. So but the cosine, right? What about the tangent? The tangent will be just the opposite over the hypotenuse, right? Or the ratio between these two, either way. So let's see. So the tangent should be opposite over the hypotenuse, which is tangent of 4. No. Tangent is adjacent, is opposite over adjacent. So 3. No, it's 4, right? It's 4 over 3. All right. And that is the same as saying, if I put tangent and I put 82, actually no, 72 over 3. 71/7 over 0.82, right? So 0.82. So yeah, so the tangent will be the ratio of this of the opposite over the adjacent, right? So and it's usually, when it's something like this, when it's something like that, that is the value of the function. So, but let's say that you want to find, so the angle, you take the inverse of that value. So it will be tangent. So it's going to be second tangent. Oops. Tangent of 4/3. All right, and let's say that you want to do, if I change the mode and I want to do degrees, right? I know that, so tangent of that, right? So it's going to be what? It's going to be second tangent, right? So it's going to be 4/3, and it's equal to 53.13 degrees, right? So those are some of the basic triangles, right? So, and let's say that I use the other one. I use the 82/3. And remember, when you find the angle, just let me touch on this. When you find the angle, what you do is you take the inverse of this. So if I am doing tangent, for example, tangent of theta is equal to the inverse, right? Inverse of that. And what is going to be? Well, it's going to be the ratio between these two, which in this case is the ratio of 0.82 over 0.717, right? And it's very close. I mean, it changes a little bit because you have a decimals, but it's still close. So yeah, so that's how you do it. So in this case, to find the angle, you do opposite, right? So to find the angle of this, you will do opposite over the adjacent, which is 3. And the value of that is approximately, because we looking for data, right? Data is equal to, when I take the inverse of that, is equal to something like a 53.13 degrees. Okay, so the tangent, that is the angle of that, right? Of the ratio between the opposite and the adjacent, right? So, okay, so let me just do another quick problem. Let's say that the problem is given to you, but just A and B are like, you know, if A and B is given, but you're missing the value on the hypotenuse, well, you do the Pythagorean theorem, find the value, and then use the value to do the rest of the step as we did in this case. So that's how you do the problem. Just in case they give you a triangle but it's missing one piece, you use the Pythagorean theorem, and then you do triangle, and then put the numbers in the triangle, and then start doing the same thing that we just did here, and that will work the same thing, right? So yeah, so that's how we do those. That's how we do basic trig. And notice that when you do the value of the, let's say, did I put the value? Let me do tangent real quick. Let me just do tangent. So we do tangent of data is equal to 4/5, right? Which in this case is tangent of 4/5 is nothing but, oh, I am in degrees, so I have to change the mode to radians. So tangent of data is 4/3. Did I say 4/5? That's 4/3, right? And that is equal to 4.13. Okay, so that is the value for that. Okay, so that's it, guys. That is basically the video for today, and I hope you learned something. If you did learn something, you like this video, and you learned something, just give me a thumbs up, give me a like, and subscribe. Thank you for watching.